Thanks, Matt. So I'm going to do my best to try to be vocal, but the cadre party last night really kind of took my voice away. So I'm normally a very enthusiastic speaker, but I may be a little bit monotone because I have a very small amount of voice to use with you guys. So I'll do my best. So when talking about performance and scalability, that's two different topics basically. Performance basically meaning making your site fast. Scalability, making it so that your site can handle a large amount of traffic. Before you even get into anything, this talk mostly is going to focus on installing software, like things that you can do on your individual server. So hopefully that means that you have like a root account on your server, or you have a server administrator that has the ability to install software on your server. That's going to be the criteria for a lot of the software that we're going to talk about. But I also want to say that there's a good chance that before you even get into that, you should start and figure out what's wrong with your site. If you're having problems with just the most basic Drupal site causing you troubles, you probably aren't looking at installing new software to actually fix your site, or to cover up the problem, if you will. Most of the time, it's really just a matter of finding what's wrong with your current site, like finding why is Drupal slow, why is my site crashing under some small amount of load. Well, there's at least a couple frequent performance culprits that you should look in depth at if you have them installed on your site. And any module has the potential basically to do absolutely terrible performance things to your site. And a couple of these modules are even included in core. The statistics module, this is one of those frequent culprits where people go to the modules page for the first time and they see statistics. Oh, I would like statistics on my site. Yes, please. And they turn on the statistics module and never actually look at the statistics pages, because the statistics generated by statistics module are actually not that helpful. So if you're using statistics module, or if you've turned it on, turn it off, because it seriously is like one of the most terrible modules out there in terms of generating a lot of SQL queries. It does an insert on every single page view to track, that somebody visited your page or something like that. And what you end up looking at eventually is that you go and look at your statistics one day and you find out that Googlebot has hit your site 380,000 times since you launched. And it's like, oh, great, that's actually 380,000 entries in the statistics table. You look at a statistics table. I've seen a statistics table of 800 million rows. It's just ridiculous. Anyway, statistics, turn it off. Use something like Google Analytics instead. Something that is something that is meant to store a lot of information. Tracker module. Tracker module essentially makes it so that every time you view an individual post, it records the user and the post combination, essentially, so you can see like the last time people viewed a particular post, or the last time they participated in it. Also, just an absolute performance killer. Try to avoid that one if you can. If you need tracker ability, use Tracker 2 from Contrib, which is a much better, more scalable version, and that is actually what's on Drupal.org. XML sitemap. Oh man, XML sitemap way back in the day used to be like the #1 killer of sites. If you installed it, it almost immediately would just destroy your site. The newer versions of it are totally fine. Just if you're running an older version, Drupal 6, 1.x branch, another problem. Sort of in the same SEO vein, NodeWords module. NodeWords even today is a real performance killer. And it really is kind of harsh for the people that have an SEO consultant come in and say you need to install XML sitemap and NodeWords, and pretty soon your site starts going really slow. NodeWords has been in a tough place for a long time, and I'm sorry to say, like right now, you really just can't install NodeWords. If you need meta tags of some kind, consider doing it through theming or through a hook page alter, something that you can use for anything to avoid that module for the time being. User relationships is a module that just has a lot of complexity to it, but is a frequent performance culprit. And any kind of access control module, OG, taxonomy access control, TAC Lite, any access control module is going to be a pretty crazy performance killer. So if you're using access control modules, a lot of times you can't avoid them. But if you are using access control modules, try to just use one and not multiple. Things get even more crazy. The more access control systems you have in place, the crazier the queries become, and the worse performance implication it has. So these and many others, I'm sure, these are just really popular modules that can cause a lot of problems. But there are a lot of modules out there that I don't even know of that I'm sure are equally big performance killers. And so if you don't know what's on your site that's causing some problems, there are some tools to help you find out what those problems are. And so the easiest one is one that a tool that everybody should have installed, and that's the devel module. And so the devel module is a Drupal.org project. You can see the URL right here. And it includes two tools, at least in the Drupal 7 branch. Has this bottom option for XHPROM, but every version of devel all the way back in time had this ability to show a query log. And the query log is absolutely fantastic in terms of finding out what sort of SQL queries are on your site that may be running slowly. So this is an example from a site that's having some issues. You can see here it executed 300 queries in 3,000 milliseconds, so it's actually 3 seconds that it was just doing SQL queries. SQL queries are the #1 slowdown on any Drupal site. And you can see here a query is longer than 5 milliseconds or executed more than once. You should never ever need to execute the same SQL query on a single page more than once. If you are executing the same SQL query more than once, you should be able to rewrite that function in some way to make it so that it remembers the fact that it's already got the result and store that in memory instead of executing it multiple times. You can see right here actually on this particular site the #1 SQL query here is statistics exit. This is statistics module doing an insert into the access log table, sort of like what I was talking about. That statistics module is just not a really great module. And it will sort them. You can have it sort by the amount of time that it took to execute. So the longest running queries are at the top, and you can see here that an insert is a rather expensive operation in comparison to something like a select. So XHPROM is a completely different approach to profiling, essentially. So SQL queries are a great thing to look at. But XHPROM and other tools like it, like Cache Grind or PHP Grind, go through it and they actually analyze your code and actually break it down by function and say this function took the most time to execute, and then sort it so you can see where all of the processing time is actually being spent within any individual Drupal execution. So both of these just show up at the bottom of the page. And in the case of XHPROM, it's a link. In the case of the query log, it's just a list right down there at the very bottom of the page. And so you just can browse around your site, and any particular page, if you're noticing it's slow, you go and look at the analysis of where the time is being spent. And this is particularly useful if you're not seeing any expensive SQL queries. A lot of times a slowdown is caused by an external HTTP request. That is a very, very common symptom, especially with things like in the age of Twitter and Facebook. A lot of people are querying external web services during individual page loads. And this will bring that to the forefront because you'll see that a bunch of time was being spent in like Twitter API call or something like that, a function that is executing an external HTTP request. So basically, your page not only has to load, but then your server has to query another server, and that page has to load, and then get the result back, return it to you, and then you return back to the user. And this will bring those sorts of problems to the front. So, step 2. So, step 1, finding out what's wrong. Step 2, and maybe this should actually be step 1. Turn on the freaking page cache. This is the #1 thing you can do to speed up your site, and it is crazy the difference that you have between a page that is not cached and a page that is cached by the Drupal page cache. And we'll get into numbers at the end of this presentation, but simply turning on the page cache, this is located at the performance page of Drupal. In Drupal 7 it looks like this. You should set a minimum cache lifetime and the expiration of cache pages to something reasonable. Like I have it set here to 5 minutes. I would never recommend that you set it higher than 5 minutes, though. That drop down goes all the way up to something crazy like a week or something like that. It is absolutely silly. The advantage that you get of something like a 5-minute cache or even a 1-minute cache is crazy. Like, say 100 users. 100's not very exciting. Say 10,000 users visit your site in 1 minute. If you have the page cache turned on, that turns 10,000 times that Drupal had to start up, read stuff from the database, and generate the page into one time. And if you turn it up to 5 minutes, then that makes it so that 50,000 users generated the page one time. It's not actually that big of a difference that you had to generate the page 5 times in 5 minutes versus generating it one time in 5 minutes, right? And when you're looking at the grand scheme of like 50,000 users coming to visit your site, so set it really low. Basically, you're not getting much benefit by setting that to something really high. So I usually say 1 minute, 5 minutes at the absolute maximum. In Drupal 6. It's similar. It looks like this, only it's a set of radio buttons instead of being a checkbox. This particular screenshot is actually not from Drupal. It's actually from Pressflow, which I'll talk about here in a little bit. Okay. So once again, before you actually get into installing new software, what you want to do is look at your existing stack and figure out how can I optimize the software I have today. Pressflow, like I just mentioned. Pressflow, if you're running Drupal 6 and you need to install performance software on top of it, you shouldn't actually be using Drupal core. This sounds really crazy, but Pressflow is essentially a complete replacement of Drupal core. It's 100% API compatible, so you can just basically remove Drupal core, replace it with Pressflow, and it's exactly, it is Drupal. It's like a fork of Drupal. In a way, it's a fork done right. That is a version of Drupal that is 100% API compatible and 100% just use all of your existing Drupal modules. But it's different in that it does things like it allows you to use like slave databases, content delivery networks, reverse proxy systems that we're going to talk about, and it basically is just a more performant version of Drupal core. Some things that they've done in it. Narrow down your use cases a little bit. You can only use it with MySQL. They've stripped out the database abstraction layer and said MySQL only, and that makes it so that it can be more performant because it got rid of a lot of abstraction that Drupal core includes. So you only need it in Drupal 6. Drupal 7 functionality-wise includes everything. Like it includes the ability to use a content delivery network and reverse proxy caches, slave database servers. All of those abilities are all built into Drupal 7 now. Pressflow, as far as like a Drupal 7 version of Pressflow, may exist soon in the future, but it will likely focus on things that Drupal core doesn't yet have. Things like the ability to use edge side includes, for example, and generate parts of the page through Varnish. Really fancy, high-performance stuff. I think they're also really big on trying to make it so that they can use hip-hop PHP. Hip-hop PHP is basically what powers Facebook, where it's basically crazy fast. Because that's all I can say about it. And the nice thing about Pressflow also does not create sessions for anonymous users, built into Drupal 7 also. And we'll talk about why that's important when we get into reverse proxy caches. So install Pressflow if you're using Drupal 6. It's just a good thing to do. It's really simple. It's just like upgrading Drupal core. Take out the normal Drupal core files, replace them with Pressflow equivalents. And Pressflow is actually really good about updating just like Drupal core, every time there's a security release or an update of Drupal core, the version of Pressflow will follow in like a matter of hours or maybe at worst a couple of days. They're a really good team. So PHP. PHP, obviously, everybody's running it if they're running Drupal. The absolute number one thing you can do is install APC. APC is another PHP cache, which reduces all of the disk access. And this is particularly super important if you're running a VM or a cloud server, because disk access on cloud servers is catastrophic. Like, that is the number one thing why a cloud server is not nearly as fast as a dedicated server, even if they're like the same specs, because disk access on cloud servers is just absolutely terrible. So APC can alleviate a lot of that problem, where whenever you request a Drupal page, the very first thing that Apache does when it starts up PHP, PHP says, oh, I need to render this page. Index.php gets pulled up, and then it has to load almost all of those files that you see within Drupal, all of the .module files, everything in the includes directory. It literally needs to read it from disk, all those files off disk, parse it, turn it into C code, compile it, and then actually execute on that and return the result back. And it does that on every single page load. If you install APC, it skips the process of reading it from disk, and it skips the process of compiling into C code because it already has it compiled, has it ready essentially, and skips a huge chunk of processing power and a lot of disk accesses, and makes it so that all that information can immediately just be executed and then returned back to the user. So APC is incredibly useful, and the great thing about it is that it's invisible. You just install it, or you have it installed, and it takes absolutely no work whatsoever. You don't need to clear it. You don't need to even know that it's there. It basically just makes things roughly about twice as fast as far as the process of building and compiling a Drupal page. It's really great. One thing you need to worry about, though, is that you need to make sure that all of Drupal, like all of the files, essentially, you can roughly think of it as the file size of all of the code needs to be able to fit in memory. And the default size of APC is something like 8 megabytes. And 8 megabytes, honestly, is just not enough space for all of the Drupal code to actually fit within memory. So what we commonly do is we set the size here to 128 megabytes. That's about as high as you can go with APC on a lot of systems. But 128 megabytes is plenty of room for Drupal to fit, and if you're running other PHP applications on the same server, they'll all fit within that memory allotment also. So you don't need to set it to 128 megabytes, but that's a good number if you have it available. If you want to check actually how much space you have available, APC comes as this really nice script just called apc.php. That is a file that gives you statistics on APC and how well it's running. And what you always want to see in APC is a 99% higher hit rate on APC. That means that APC is not needing to load, or PHP is not needing to load from disk any of the files hardly ever. Like this is about your typical screen here, where you've got a 99.7% hit rate. That means that 99.7% of the time you don't need to read from disk, and that APC has already got all of that information in the cache already. So that 0.3% is really like the very first time you restarted APC, and then it needed to load all of the files from disk for the first time, and then it will never need to do that again. So you always have like a super high hit rate. If you're getting a lower hit rate, that usually you'll usually see this in combination, that the hit rate will start to drop. It'll actually be like usually it's like a cliff, where the hit rate drops all the way down to something like 5%, and the cache over here, the green pie slice, is completely gone. It's all orange, meaning the cache is full. If the cache is full, that means that APC is clearing stuff out of the cache before it actually gets to be used. So if you run out of cache space, the orange pie is, or the pie is completely orange, and APC doesn't have enough space actually to function properly. So you increase the size, the hit rate will shoot up like crazy, and then you're in the situation where APC is working like it should again. let's take a break. I know I'm fire hosing information at you guys. Have we got any questions so far? Anybody in the room? Yeah. Matt, could you repeat that?
I'm sorry, I did not hear your question.
Should we enable internal debugging
Should we enable internal debugging? Is that a good idea?
So, internal debugging, you mean like something like Xdebug, and then using
when you install it? When you install it,
It's asking you when you install it. Are you talking about APC?
Yeah.
So internal debugging with APC, should that be installed?
Oh, okay. So yeah, there is a debugging thing that comes with APC. Should that be installed? You can install it on your server if you want. It may actually, I'm not actually sure. I'm not actually sure if that's Xdebug. I don't think it's Xdebug. I think APC actually comes with some kind of debugging thing straight up. I've never actually used it, so yeah, I don't think it's necessary. No.
Are there any further questions?
I know you mentioned access control modules like organic groups and user relationships, with problems. But something that binds that users get discount and all that.
The question was, you mentioned access control modules can really cause you performance nightmares. What if you really need one of those?
So if you really need access control modules, and we use access control modules even on our own sites that are like super high performance sites, we actually use the domain module, which basically applies access control so that you see content on one particular domain and not on another domain. So it allows you to run multiple sites, basically completely different sites and domains off of one Drupal database. And those kinds of queries are expensive, and if you see if you turn on query logging, you'll probably see that a lot of those queries are actually, whenever you do a listing of nodes, actually is the common thing that gets affected. You'll see those queries start to float to the top of the list in terms of being expensive queries. So what can you do if you need those things? Well, I'll talk about it a little bit here. Actually, there's a good lead-in here into MySQL, because what access control modules do is they generate queries that are complicated, basically. They make it so whenever you have a listing of content, it needs to join against the access table, or the node access table. And then the node access table then does another join onto whatever module table that is. And that all of those joins basically form an expensive query. And you can mitigate the problem essentially by optimizing MySQL well, and I'll talk about it here in a little bit, using slave servers to make it so that those queries are hitting not your main database server. So let's talk about MySQL. So MySQL, like I just said, in multi-server setups, you can utilize slave databases and all pagered queries. So anytime you have a query that has multiple pages, like the river of news that you get on the home page of Drupal sites by default, that would be an example of a pagered query where you've got multiple pages of content. Or if you have any kind of limit, so like if you build a view and you say only show 10 items, then that query will hit the database or the slave database instead of the master. And this only actually applies if you're running Pressflow, which is why I've been telling people that you should use it if you're on Drupal 6. In Drupal 7, actually, views has a very nice checkbox underneath the query settings. It just says use slave server. So in Drupal 7, it's much more straightforward. You just say, I want this query to hit the slave. And if you have a slave database server in Drupal 7, you should pretty much do that for every single view you build. Make everything hit the slave. So the idea is to protect the master database from queries, because the master database, when it comes to scaling out, like adding hardware, throwing hardware at the problem, the master database is the one part of your infrastructure that you can't scale out. You can't just add another machine. You can upgrade your master database to be a really fast machine and a really big, like 16-core, 24 gigabyte or 24 gig monster, basically. But you can't actually add more machines at the database layer. at least as far as like there's always one database system that is actually receiving all of the inserts. But configuration-wise, I'm going to talk more about master and slave databases. But configuration-wise, there are two things that you can do that are always huge wins on the MySQL layer. And the first of them is turning on query caching. Query caching basically is a small cache, like 32 megabytes usually, of cache that just remembers the answer to particular queries. So Drupal, when it generates pages, will end up doing a lot of the same queries very frequently. And turning on the query cache will just have MySQL store the result to queries that are frequently done in memory instead of needing to access them from disk. And in Drupal 7, InnoDB is the default engine or storage engine. And InnoDB has particular caches also that you can set that need to be set to a pretty high number. I'm going to talk about them in a second. If you need help actually configuring your MySQL parameters, there's a bunch of other things besides query caching and the InnoDB buffers. Those are the two biggest ones. There are two extremely helpful scripts that you can run. So you guys don't have to actually write down all these URLs. I've posted the slides on the Do It With Drupal site. If you go to this presentation session, you'll see that there's a link there to download the slides. But these two scripts, basically they're shell scripts. They're written in Perl. And you download them onto your server, and then as a root user on the site, you simply execute these particular scripts, and they'll tell you everything that's wrong with your MySQL configuration, which is really, it's really pretty awesome. They're not a substitute for knowing what you're doing, but they're a really good learning tool in terms of like finding out what's wrong with your database and just setting off like little red flags, basically saying things that you can fix on your server. So oftentimes what they'll do is they'll tell you to turn on query caching and set the InnoDB buffers. So here's what this actually looks like. So this is in your my.cnf file, the configuration file for MySQL essentially. And this is what it looks like to turn on the query cache. The query cache first up here and then InnoDB buffer down below. So you can see here I've got the query cache set to 32 megabytes, which is going to be pretty reasonable for most servers and sites. A query cache limit basically saying that I will store at most a 1 megabyte size for like an individual query. And the query cache type, you could look up the details of what that actually means, but it's technical. That doesn't really just say 1. So, and then down below, this is setting the InnoDB buffer size to 128 megabytes, and then setting the flush method to direct. And up here at the top, I've got links to two particular articles on why you set these to what they are. The flush method basically prevents the operating system from doing caching on top of InnoDB or MySQL doing its own caching, so it reduces redundant caches. There's no point in having caches at two layers doing the same things. But the InnoDB buffer pool size is a really interesting parameter to set because just about everybody will tell you if you have a dedicated MySQL server, you set this InnoDB buffer pool size to just ridiculous numbers. A lot of people will say 2/3 of the available memory on your server. If you have a dedicated MySQL box, this can go all the way up to something like 10 gigabytes of size if you have a dedicated server. Because as far as InnoDB goes, that cache size, the more you give it, the better MySQL runs if you're running InnoDB database tables. And it just basically has no limit at all to bigger is always better when it comes to this particular setting. So I've got it only set to 128 megabytes, which would be a typical setup if you're running like a virtual machine of some kind or a single server that has both like MySQL and Apache and the whole stack all on one machine. Then this might be a reasonable start.
InnoDB is your preferred engine?
Yeah. So talking about database engines, there are two really big database engines out there. There's MyISAM, which is typically the default. In Drupal 6 and before, MyISAM was the default database engine for MySQL databases. InnoDB, on the other hand, is the default for Drupal 7, so all tables are InnoDB by default. And basically, the difference between the two is that MyISAM is highly performant at read queries. So if there's a select star or count or any queries that need to do calculations on tables, MyISAM is more performant. InnoDB, on the other hand, is only slightly less performant on the select side, but ridiculously more performant when it comes to doing insert queries and update queries. So generally, as we found ultimately with Drupal 7, is that doing InnoDB across the board is way, way more beneficial than using MyISAM. If you want to be really picky about it, you can actually have some database tables use the MyISAM MySQL engine and have some tables use InnoDB. And tables that you want to be InnoDB are ones that are receiving a lot of write requests. So that might be things like the node table, the user table, the access log, the sessions table, watchdog. Any of these tables that receive a lot of write requests, you might set them to InnoDB and then set everything else to MyISAM that is mostly read-only requests. It's getting pretty heady, though, talking about MySQL engines, like comparing them to each other. I typically just say use InnoDB across the board, just because it's the better decision. So that's what I would say.
Question in the back.
How hard is it to convert an existing database? Is it possible?
How hard is it to convert an existing database? You're saying to change engines on your tables?
Yeah, how hard is it? It's as simple as a query. Essentially, you execute against MySQL and it will convert it from one engine to another one. It may take maybe a second to actually do the conversion. So if you do all of your database tables all at once, you may be looking at like a 30-second sort of conversion time. There's actually some modules out there that can help you with this. I think it's called DB Tools.
DB Tuner?
Oh, DB Tuner. Yeah, DB Tuner. That actually will tell you what engine all of your tables are and will allow you to convert them from one to the other. Great question. Any other MySQL questions?
Is there a limit to how much cache you can create, and also the delays when the cache is cleared?
And you're talking about MySQL cache? The question was, is there a limit to the cache? And will there be issues and delays and stuff when that cache gets cleared?
So MySQL essentially will always take care of clearing its own caches, and it's not. You may be thinking of like the Drupal cache when you hit like flush all caches button. That has no effect on MySQL. The MySQL cache is self-managed. Drupal doesn't even know that there is a cache in place. So MySQL is managing all of its own caches at a layer that Drupal is not even aware that there is caching going on. So there isn't actually any flushing of the cache like we see commonly in Drupal, because MySQL is smart enough that it's basically managing all of the cache all the time for you. So you'll never actually see a flush unless you actually like restart MySQL, which will actually clear everything out and actually turn it off and then turn it back on. So and there was some other question about a limit, right? I can't remember what that was.
Yeah, is there a limit? I think that's a very deeper question. It all depends on how much time you have.
Yeah, actually, a really, really good question, which amazingly leads into my next slide again about what kind of limits you can set on these things. Because you're right that there's only so much memory available on a particular machine, and memory actually is a huge thing that you need to take into consideration when it comes to how big all of these things are. Like those scripts that I was talking about will tell you the maximum amount of memory that MySQL will take up. MySQL, when you run those scripts, it'll say MySQL is currently configured to use a maximum of 2.3 gigabytes of memory, which is really awesome. It basically takes the number of max connections that you have, the amount of memory it takes per connection, and then the amount of caches that you have set, and adds them all up for you to calculate a total number that MySQL will take this much memory at maximum, which is super helpful. Apache, on the other hand, I haven't yet seen a script that does this. I guess maybe it's so simple it doesn't need a script. But Apache is where most people go wrong in terms of the amount of memory that they allot to their box. There's a lot of things that you can talk about in the world of Apache, like the way Apache works. There are two popular engines out there for Apache, like Prefork or Worker, which Worker you're normally using with Fastcgi, and Prefork you're usually using with Mod PHP. So Fastcgi versus Mod PHP, using htaccess files like local htaccess files versus like moving all of those htaccess files into virtual hosts, whether or not you have keep alive on or off, and disabling unneeded modules. There's a lot of modules that Apache comes with that you can turn off that you don't actually need. All of these things, while important, are not nearly as important as calculating the amount of memory that Apache will actually consume. All of these things, you can argue one or the other, and actually in some situations it makes sense to do one over the other. In just about every site you'll need to decide, a particular situation where you want to use something that's not the default. The defaults of Apache are usually pretty respectable. By default, you'll be using Prefork and Mod PHP almost always, which has a performance advantage typically over Fastcgi and Worker. Fastcgi and Worker, typically you may be able to squeeze some more connection ability with less memory in those configurations, but they're not quite as fast. There's just totally minor trade-offs between the two of them. And honestly, Mod PHP and Prefork are just a lot simpler to work with, and they're more stable, that most people stick with them. So all of these things, you can configure them in various ways, but the one important thing that you really want to pay attention to is max clients. Max clients essentially is the number of connections that Apache can receive or handle. And this particular setup, this is the Apache defaults. The Apache defaults has max clients at 256, meaning that 256 connections can be handled by Apache at any point in time. So it'll try to handle 256 people simultaneously. 256 is a really high number, actually, especially if you're running Drupal and Mod PHP. The size of every individual Apache instance, if you use top or some other utility to check the memory usage on your machine, you'll see that a typical Drupal install will probably take up anywhere between 40 and 80 megabytes in every single Apache instance. So if you take the max clients and you multiply that by the average, just looking at top, and see, oh, this particular HTTP on my server is taking up 40 megabytes per instance. 80 megabytes is not uncommon, depending on the number of modules and things that you have installed on your site. Take that, 256 times 40 megabytes is 10 gigabytes of memory. And Apache will just keep sucking up memory as if it was candy, even if it doesn't exist on your server. It will just continue expanding and take more and more and more memory. And what your server will try to do in this situation is it will try to allot memory even though it doesn't exist. And that's when it goes into swap. Swap is essentially disk-based memory, where when the server runs out of memory, it says, oh, I'm out of memory, so I'm going to start writing memory to disk. And especially on cloud servers, that is an absolute catastrophe. Touching the disk is always the slowest operation you can possibly do, and you want to avoid it at all costs. If you've configured Apache or left it at the defaults, setting max clients to too high a number is absolutely catastrophic. If the server runs out of memory like that, or continues to allocate memory even after it's run out, it goes into a really nasty spiral of death. You won't even be able to SSH into it. The server literally will go down, and just about the only thing that can fix it is a reboot. It's really catastrophic when this happens. So this is the absolutely most important thing to do, is that calculate all of the other services that you have on your server, how many caches you have set for MySQL, which the scripts will tell you MySQL will take up this max amount. and then other services, which I'm about to talk about, add up all of their memory allotments and then only give Apache basically what's left. And that basically will tell you how many people you can serve up at the same time. If Apache runs out of connections, it's much better to have it so that the server just returns back, I'm sorry, I can't serve your request right now. It'll just time out, essentially. And timing out for some users, basically some requests will be fulfilled, some of them won't, is a much better situation than all requests being shut down because the entire server is down, which is what will happen if you set this too high. So this is basically the end of configuring software that you've got. So we've got PHP, we've got MySQL, and Apache, the typical configurations that you have and things you can do to help them. Do we have any questions on this segment?
Question right there.
Yeah, can you bring that HTTP size down?
The actual memory allotment of HTTPD. Can you bring it down? Basically, the amount of size that it requires is basically the amount of memory that it actually takes to build and execute Drupal. That's what you actually see inside of the HTTPD size is basically almost entirely PHP and the things that PHP is needing to execute. So generally, the more modules you have installed on your site and the amount of code that it needs to execute increases the size of HTTPD. So the way to improve it or make it smaller, essentially, is to use fewer modules. It sounds kind of crazy, but on the application layer, the more complex your application is, the more memory it requires PHP to actually execute that code. So it's something you don't hear a lot in the Drupal world, but sometimes you really need to look at the amount of modules and the amount of code that Drupal is executing because it's a big application. And with things like views and panels, those are big applications. And then things that you might add on top of those that just can really balloon the size of Drupal itself, just purely the amount of code. So there's no magic bullet to shrinking the memory size of individual HTTPD requests. Or if you're running Fastcgi, PHP actually runs as its own service, and it will then inflate the amount of code that it needs to execute. So the only thing you can really do is optimize your application and use only code that you actually need.
How do you measure that value? How do you know it's working?
The question was, how do you measure that value?
Mm-hmm. So if you've connected to the server, usually through a terminal of some kind like SSH, I say from top here, and I made a poor assumption that everybody knows what top is. Top essentially basically is like the process manager that just lets you know what processes are currently running on your machine. And if you type in top on a command line, it will show you, by default, to show you things that are using a lot of CPU. But it'll also show you each individual process is consuming this amount of memory and this amount of CPU. And you can just look at all of them. You could actually sort by memory usage by pressing the letter M. It'll sort by memory usage. And then just take an average of what Apache is currently using right now and calculate the total from that.
I believe we had one question in the back as well.
Yeah. With APC, by the way, this question is kind of someone else suggested this issue. I don't want to come up with. Have you seen any benefit by turning APC stat off? And just to describe what APC stat is, it's caching everything, but APC stat's a way that it checks files if they've been modified. And you can turn that off, and then it never hits the disk. But if you update your PHP code, you have to clear the cache. And I guess my question is, have you used it? Have you seen a benefit? Is it worth even considering mucking with that setting?
The question was regarding APC stat, a setting within APC, and is mucking with that particular setting going to give you any performance benefit?
Yeah, so you're right, and you described it quite adequately, that it basically is a feature that makes it so that every time you update a PHP file, APC basically is keeping track of whether or not that file has been changed, which is why I was saying APC is so nice that it's like it's pretty invisible. You just install it, you never have to think about it again. Because every time you update your code, if you deploy new changes to the site, APC automatically figures out if that code has been modified or not, and flushes its caches appropriately and rereads it from disk. And APC stat is a way of making it so that it doesn't essentially do that check. So I've never actually used it. I've never actually implemented it because I find that I like APC to be so it's so convenient the way that it works by default, that the convenience there is really high. And the actual performance advantage of it, unfortunately, I haven't benchmarked it, so I don't know what kind of benefit it's actually giving you. But yeah, thanks for bringing that up. That's a really, really good question. Okay, so now we've talked about finding the problems with your site and solving them just by doing a little bit of regular benchmarking. We've talked about turning on the page cache. That was step 2. And then we've talked about configuring the existing software that you have. And I made the assumption that people are running MySQL, Apache, and PHP. After you've gotten to this point, now is the time that you can actually start looking at adding additional software to your server. And this is really where the performance numbers can just go absolutely crazy, like in the things that you can do. So the first thing I'm going to talk about is Memcached. And Memcache, the D at the end, I guess, is for daemon. So some people say Memcache, Memcached for the actual daemon itself when it's running. Memcache is essentially a way of alleviating load on your database server, where instead of doing MySQL queries to store stuff in the database, Memcache is an object store or a key value store that allows you to store things directly in memory. So common things that may be stored in memory, if you turn on the page cache is literally the beginning of the HTML file to the bottom of the HTML file, and then Drupal simply takes that and shoves it into the database. And the next time that page is requested, Drupal just says, "Oh, for this URL, get the page cache," and it will load it from the database, and then return it back to the user. If you're using Memcache, Memcache will replace every single table in the database that starts with the word cache. Cache, the actual cache table, cache page, cache filter, every individual cache table. Instead of being stored in the database, it's now stored just directly in memory. And it makes it so that when an anonymous user comes to your page, Drupal starts up. Hopefully you're using APC. So APC is read from memory, or all the files are read from memory. And then Drupal starts up, and the very first thing it does with the page cache turned on, it checks to see if that page has already been cached before in the last couple of minutes. And if you're using Memcache, that's from memory too. So you'd have Drupal load the page cache and pull from Memcache, and ultimately what you're striving for essentially is a disk-free page serve. You want to be able to serve that page without touching the disk at all. And Memcache essentially is a really good tool for furthering that goal. The great thing about Memcache also is that Memcache also has a huge effect for authenticated users, because there are a lot of caches that Drupal has that are like individual parts of the page. Like if you use the block cache or views module, allows you to cache the actual rendering of any listing. And whenever you use any of those caches, they all go into whatever cache system you're currently using. And Memcache essentially basically replaces all of the existing caches out there. And instead of storing all those caches in the database, they're all stored in memory, which is really, really fast. So when it comes to Memcache, you used to have to do this terrible thing in older versions of the Memcache module. You need to start an instance of Memcache for every individual cache table you had on your site. And that was a crazy pain. Newer versions of the Memcache module do it correctly, and they simply use one big bin, essentially, one daemon that is started up on the server. And then all of the cache tables are stored in that one individual bin, which is much more convenient. So 128 megabytes is a good start. So when you turn on APC, when you turn on Memcache, you get to define how much space it will take up. And 128 megabytes is a good start for a Drupal site. Just like the APC statistics, Memcache comes with a file also called memcache.php. I didn't mention it in my last one, but almost all servers have that apc.php file and this memcache.php file. If you've installed Memcache, you probably have that file somewhere on your server. But where it is depends on the architecture and the way you decided to install Memcache and APC. So I always just tell people, just run a find command on your entire server and you'll find it somewhere. It's there. It's crazy. It's on everybody's server, but nobody knows it's there. And it's always in weird locations. So you can find that Memcache file and just copy it to your web root and then load it up in the browser. And it will tell you information like this. Or if you don't have it on your server, or if you just don't want to wait for the find command to search your entire machine, you can just use wget, which is essentially like just a download command to pull that file directly from the Memcache project or the APC project. So this will actually just pull it down, put this file into your web directory, and then go look at it in a browser. And this is the same thing where you can look to see how much memory Memcache currently has available. And you always want to have Memcache have a slice of green space available. If the cache is entirely full, that means that it's disposing of things that are still useful to make room for other things. And that's when you'll see your hit rate absolutely plummet. Unlike APC, though, the new Memcache module doesn't have a super high hit rate. So seeing something like this where even if you were to get all the way down to like a 50% hit rate, it's nothing to really worry about. That's just the way the module works. But what you do always want to make sure, that Memcache still has a big chunk of free memory available. If it's filled all the way up, allot Memcache more memory and then restart the service so that it can fill up and then have space available. So room to grow and not throwing away stuff that's still useful. So Memcache, absolutely great. And when it comes to performance, generally like the first piece of software that we add to sites, mostly because it's very versatile. It works for both authenticated users and anonymous users, and it gives big boosts to both of them. So search is one of those things on a Drupal site, especially if you're using just the search module that comes with core. Search is really, really CPU intensive. It's a really expensive operation to do a search. And if you're using the search module that comes with Drupal core, you can get yourself into a nasty situation where if users are executing a lot of searches, it's taking a lot of CPU cycles and a lot of database connections to execute those searches. And because users are searching so much and the database or the web server are all the same thing, all of those searches actually end up taking your server down. So people, by executing a lot of searches, it's a really likely way for your server to come down. Apache Solr is a separate project. It's important to know that it's not PHP based. It's not even like Apache, like HTTP based. It's a Java application essentially. And that means that in order to run it, you need to install Tomcat or some other Java server to actually use it. So Solr, unfortunately, is a little bit of a bear to install, but it's really, really great in terms of what it can do. It's wildly more efficient than Drupal-based database searches. And my favorite thing about it is that you can put it on a completely separate box. And I really recommend that if you've got multiple machines available or if you're using cloud servers, that you should put Apache Solr on a separate box than your web server. That makes it so that if people are executing a lot of searches, and that's a really popular feature on your site, the worst thing that can happen is that search stops working, because as people are executing so many searches, the search server goes down, but the rest of the website stays up. And having that decoupling between your search and the rest of your site is a really good thing. So there are two ways that you can use Apache Solr once you have it installed on your server. There are two projects out there. There's the Apache Solr project and there's the Search API project. And both of them are excellent, which is really great that we've got two systems that are really fantastic. Apache Solr is more like a out-of-the-box, everything just kind of works module. And Search API is basically like a starter kit that you can install a whole bunch more modules on. It's more versatile and it has more capabilities. And if Apache Solr doesn't have the features you need, consider looking at Search API. Another really cool thing about Apache Solr is that it doesn't even need to be even on your local infrastructure. Doing a search actually across the internet actually can oftentimes be faster than if you were doing a MySQL-based search in Drupal on a local database. And Acquia actually has a search product that you can purchase independently of everything else, and basically just purchase bandwidth from Acquia's cluster of Apache Solr boxes, which is really great because that is a really high capacity too, considering they serve a huge number of people. They have a very nice cluster of servers that all operate all of that all together for you. So if you don't want to install it, consider a subscription. It's a good idea. So, Varnish. I love Varnish. Varnish is an application that you stick in front of Apache, essentially. So, what it's capable of doing is it sits in front of Apache. You just have Apache on your server, most people are using it, or you have something else. You can actually stick Varnish in front of anything. It doesn't matter. You make Varnish sit in front of that application, and you have it accept the HTTP request. So you put it on port 80, and then you put Apache or whatever you're using as your web server on the back end on a different port, and Varnish essentially acts as an intermediary. It takes the requests. If it has a version in cache, it will just return that version back immediately. If it doesn't have it, then it will ask the web server on the other port for a copy of that page, and then it will remember it from then on out. And so Varnish particularly is very powerful for anonymous users. Most sites have this crazy imbalance of registered versus anonymous users. Like 99% of all requests are almost always anonymous users. Even if you think you have a very social site, like Drupal.org actually, Drupal.org still doesn't push like 20% authenticated. It's still mostly anonymous traffic, even on a site that has a lot of user-generated activity. And Varnish essentially is a tool that makes it so that that page cache that you may use in Drupal, it makes it so that the page cache is basically stored outside of Drupal. It's stored in an application that its entire purpose is storing stuff in memory and saying, hey, do I already have this page in cache? And if so, return it back immediately. So it's basically a dedicated application for serving up cached pages, and it is ridiculously fast. The way that you need to make it work with Drupal, though, is that you typically configure it so that if the user has a session or a cookie, it will pass through Varnish and then go to Apache and just load the page normally. And typically to set this up, there's a lot of configuration that can be done, and Lullaby has written several articles on actually how to configure Varnish for Drupal that I suggest just doing a Google for Lullaby Varnish and you'll find the articles. To make it so that if a user has a session, then they pass through to Apache normally, and everything continues functioning. So it's really fantastic. It's basically just a piece of software that you put in front of everything else, and it handles pretty much all of your anonymous requests. And even for authenticated users, it can free up a lot of activity because it still serves up all of your CSS, all of your JavaScript, all of your images can all be served from Varnish, and you specifically only allow Apache or your web server to generate things that need to be dynamic. So it really takes a huge amount of work off of Apache, and the only thing Apache needs to work on, or your web server needs to work on, is generating PHP pages, essentially, and Varnish takes everything else. So once you install this, you'll see your traffic to your web server just absolutely plummet, because it's not worrying about serving up all of these other things. The only thing it's responsible for now is the HTML, which is just great. So I was going to talk about, so I also mentioned here that we have a cookie-based skipping of whether or not Varnish is responsible for the page. Pressflow comes with a module. Drupal core and Drupal 7 doesn't have a module at all. And I haven't actually yet seen a module that does this, so I threw it up in a sandbox yesterday for everybody to use in the class. And this is our cache buster module that we install on all of our sites that run Varnish. And essentially what it does is if a user submits a form, it sets a cookie called no cache, and that no cache cookie we usually configure Varnish so that if a no cache cookie exists, Varnish will not cache the page. So the general idea here is basically that anytime a user submits a form, they become sort of like a special anonymous user. Like if they log in, it sets the no cookie or the no cache cookie, and it makes it so that all of their pages are now being generated by Apache. But for an anonymous user, basically this grants you sort of a special privilege as an anonymous user who has interacted with the site. For example, if you're an anonymous user that posted a comment or an anonymous user that submitted a poll, you may want that person's comment to be visible immediately to that user, but it doesn't really matter that everybody else on the internet doesn't get to see that user's comment for the next 2 minutes. You know, that's not a big deal. The user wants to see their comment immediately, but the fact that it will take a minute or two for everybody else on the site to see their comment usually isn't a big deal. So this sets a no cache cookie that makes it so that Varnish basically says, oh, for the next minute, I'm going to pass your request through to Apache, and so that way you can see your own comment. And then after a minute, the Varnish cache will expire, and then everybody will be getting the anonymous version again, including you. And then after that minute, you're getting from Varnish instead of Apache again. So a little bit complicated, but if you're having trouble with like anonymous users not seeing their own changes, it's because of Varnish serving up the anonymous version of that page without including their change, and then you have to wait for it to expire before you see it. So let's look at the whole stack. So this is basically in order of who's going to be taking the requests. If you have a purely anonymous user, almost always they'll only get to Varnish, and the entire rest of your stack will never ever be touched, which is great. This is what I was talking about. No disk access required request, which is what you're always striving for. Have Varnish store everything in memory. A request comes in, it basically takes the request and immediately returns it back. If you have that no cache cookie with that special module enabled, some of your requests may pass through to the Apache, PHP, and Memcache layers. And less of your information will get to the slave, which will do all of the read requests, and even few of your queries will actually get to the master server. And this is what I was saying, that the master server essentially is the one thing that you want to protect in your entire infrastructure, because it's the only thing that you can't just add another machine to. If you're in a situation where you're reaching CPU capacity on your web servers, you just add more web servers. It's great. But you can't do that with MySQL, with the master server, at least with Drupal. And so what you want to do is you try to like defend that server as much as possible. We're running short on time, and there's just so much more to talk about. So I'm going to have to like breeze through this next section, which is too bad because I love talking about this stuff. Nginx is totally awesome, and it's like the new hotness in server software. Nginx is basically a combination of Apache and Varnish put together, where it is your web server and it is your reverse-proxy cache all together. The greatest thing about Varnish is that you just take your existing infrastructure and you slap Varnish in front, and you don't have to change anything. Nginx, if you're starting from scratch, is a really good option for providing all of the capability and speed of Varnish and the ability to serve up HTTP pages like Apache all together in one piece of software. So it's really, really pretty awesome. If you're starting from scratch, you may consider Nginx. But really, in terms of speed, Varnish still has like the slight advantage when it comes to anonymous users. So let's get to the smackdown, this is what I spent like all week putting together, and it's so sad that it's at the very end of my presentation that I almost don't even get to talk about it. So Apache straight up, this is with no configuration on Apache. This is typically like what you get on like a shared host, no APC, no Memcache, nothing. If you're having Apache generate Drupal pages, you'll probably get something around this level of performance, 3.4 requests per second. Really kind of pathetic. These numbers are all generated with AB, Apache Bench. So really your numbers actually may vary depending on the actual setup of your server, but as far as comparing them to against each other, the numbers are going to be pretty accurate in terms of like the ratio of what kind of performance improvements you see. So out of the box, you get about 3.5 requests per second for Apache. And turning on APC, like I mentioned, basically gives you like a roughly doubling of the speed that you get because it's not reading everything from disk on every request. So APC, a nice doubling here. If you install Memcache, roughly a doubling also, and this really depends on how you've configured Drupal. It may not be this drastic. This is without the page cache turned on. When you turn on the page cache and you have Memcache in front of it, you get 250 requests per second, right? And that's actually, this is really respectable. You can run any site typically on that kind of number. So let's talk about Nginx versus Apache. So this is on authenticated users. So this last slide where I talked about you had Memcache enabled. So 12 requests per second essentially without the page cache. Once again here on this slide, that same 12 requests per second. So this is on authenticated user without the page cache turned on. Apache versus Nginx. Nginx has a slight advantage in the smackdown here that it can outperform Apache slightly. So if you have the ability to install Nginx, Nginx is really got the advantage just about all around. The real advantage here is in the land of HTTPS or secure connections. For logged in users, this day and age with things like Firesheep out there that allow people to immediately hijack other people's sessions if they're on a Wi-Fi network, you really should consider any time a user logs into your site, no matter what, you put them on HTTPS. You really should be looking at that in this current day where there are so many tools to allow people to hijack sessions. So Nginx has a major advantage here in terms of the ratio of how much performance loss you have by doing all of that encryption. The majority of the work when you're doing an HTTPS transaction is the initial handshake where the browser sends over a key, the server generates a key and then sends it back to the user, and then they use those keys to communicate to each other. That initial handshake process is the majority of slowdowns that you see with HTTPS. And Nginx has a pretty major advantage here in that its handshaking process is just a lot faster than Apache. So Nginx, really pretty awesome, especially for authenticated users and encrypted traffic. So now let's talk about if you have Varnish or Nginx in front of you, or actually, I haven't even mentioned this, and this is a really good thing for people that are on shared hosts or in a situation in which they can't run, they can't install their own like real reverse proxy server like Varnish. The Boost module is pretty awesome. It's really gimmicky, and performance geeks like me like to make fun of it that it's not a real reverse proxy cache. But all of the numbers we've been talking about so far, we got like 250 requests per second. It was our best number. Starting with the Boost module, if you just have Apache serving up static HTML files, which is what the Boost module does. It takes pages, turns them into static HTML files, and then puts them on your server. You're getting 1,500 requests per second. Crazy fast. Apache's actually it's not that bad actually if it's just serving up static HTML. It's pretty good at that, really. And 1,500 requests per second is definitely nothing to sneeze at. But compared to real performance software like Nginx, you're talking crazy fast. So 6,500 requests per second. That is just insanely fast. Or Varnish, 8,000 requests per second. It's just ridiculous. Like, I mean, at this level, you're really talking about saturating your network connection. Somewhere, it depends on the amount of data you're actually transferring or the size of the files you're transferring. But somewhere around like the 2,000 to 3,000 mark, you'll saturate your network connection anyway. So these things are just so fast that you should always saturate your network connection. So whether that's like 12 megabytes per second on a 100 megabit connection or 72 megabytes per second on a 1 gigabit Ethernet connection, you should be able to saturate your network connection before your server starts having high CPU load. If you're only serving anonymous users and you're seeing a lot of like your server goes down because of high traffic, that should never happen for anonymous users. You should always saturate your network connection. And the worst thing that should happen is the site starts to load slowly as network connections can't get through. If you're seeing any kind of situation where you're bottlenecked on CPU or memory, there are things you can do, like any of these solutions here for your anonymous users, that make it so that you should saturate that network connection way before you have any CPU or memory problems. So totally just about entirely out of time, but I want to talk about scaling out. Like I mentioned, the great thing about web servers is that you can always just add more of them. But as soon as you add more than one web server, you need to start load balancing between them, so distributing all the requests between them. Varnish actually has a really fantastic ability to load balance also. So you can actually stick a Varnish box in front and have it load balance between multiple Apache servers. Typically, if you split out your web servers, that also means that you need to split out the database, so the database lives on its own box also. We like to put Memcache on the database server just to have it be a central store of information. And something that a lot of people don't think about but is absolutely critical is all your files need to live in the same place. Like if a user uploads a file, say they upload a file onto server 1, and then they save the node, and then they get server 2 that doesn't have that file on it. So typically what you'll do is you'll use some kind of network attached storage or NAS or SAN to basically share all your files between all of your servers. So they're usually connected via an NFS mount. So the NFS mount, you may store Drupal on the NFS mount, and you may just store the files user upload on the NFS mount. And then hopefully you've been able to separate out your search onto its own server. And then if you're working in a high availability setup, like a Lullabot often is facing, you need to add backups on every single layer. So you've got backups for Solr, you've got backups for MySQL. The nice thing is you can often turn your backup of MySQL into a slave and generate slave queries against it and have a load balancer backup. The web servers themselves are backed up because they're already redundant, so you've already got multiple servers there to serve out the load. So, whew, I've got more slides yet, but we just don't have the time to talk about them. I'm just going to show you. If you have a slave server, I mentioned that select queries, you can make all select and ranges go against the slave. And this particular slide just shows you anytime you have a view, that view can be a listing. And when it comes to looking at things, if you look at the entire page, the amount of content that you can pull from the slave server instead of the master server is pretty significant. All of these parts of the page can all be queried against the slave server instead of the master. So if you're running up against MySQL issues, slave servers can really aid in fixing that. Some links for you guys, lowliest.com. All of the software that I mentioned, we've written articles on all of them, on how to install them on multiple architectures, on macOS, on CentOS, on Debian. We've written articles on a lot of these pieces of software and how to install them on all of them. 2bits is a really great website. A friend of ours that is really good at basically squeaking performance out of really small boxes. So it's like the ultimate site for, I only have one machine and it only has 512 megabytes of memory. How can I get the most out of it? 2bits has got a lot of fantastic articles. MySQL Performance blog, a couple of the links earlier that were shortened are from there. And then these two down here at the bottom. If all of this sounds like it's way too much work for you, and you're like, oh man, all of this software, that all sounds really hard, and it's tough to install that, our friends at Pantheon and Cadre both have managed support that just has all of this software installed for you out of the box. And it's basically, you go there, and they're Drupal people, and they have stacks special purpose built with all of the software I've talked about all together on one box for you. And so all you have to do is basically, pay your monthly fee and throw your Drupal site up there, and it will be crazy fast. So, an option for hosting instead of doing it yourself. So, am I all totally out of time? Well, no time for questions, but corner me and we can talk. Thank you guys very much.
you.